Welcome to the online lecture on forecasting. This is the agenda for today's lecture. First, I'll cover the key definitions and principles of forecasting. Then, I'll introduce to you the 7 basic models of forecasting. To evaluate whether a model performs better than the other, we can measure the forecast error. Here we have 3 techniques. First, the mean absolute error, in short MAE, the mean square error, MSE, and the mean absolute percentage error, MAPE. Then I will give a quick note on expert panels and subjective forecasting. I will then wrap up with some of the key takeaways from today's lecture. Now, imagine that you had a crystal ball that will show you the future. What type of things would you look for in the crystal ball? Next week's winning lottery numbers, the stock market data for next year. Being able to foresee the future is an ancient dream of mankind, and being able to predict the future and to forecast what will happen will come with substantial economic advantages. This lecture will be about forecasting future events. In particular, we want to forecast the future demand for the products or services that we supply. The better we are able to forecast the demand, the better we are able to match the supply with demand. And as we know from the first lecture, this is Operations Management 101. Now, before I go on further, I should break the bad news that, unfortunately, I cannot offer you a crystal ball. In fact, to the best of my knowledge, I do not think there exists such a thing. But the absence of crystal balls does not mean we cannot make good forecasts. Well, we might not be able to make perfect forecasts, but as you will see, a little bit of intelligence goes a long way. So first thing first, let's introduce 2 key definitions related to forecasting. First, what is forecasting? Forecasting is the process of creating statements about outcomes of variables that presently are uncertain and will only be realized in the future. What is demand forecasting? Demand forecasting is then the process of creating statements about future realizations of demand. Take a moment and look through these statements again. Now, let's apply this into an example. So some of you might be aware of this story. During the FIFA Soccer World Cup 2010, zookeepers in a German zoo made international headlines because they were able to forecast most of the outcomes of all matches of the German team, including Germany's loss in the semi-finals against Spain. How did they do this? The zoo had an octopus by the name of Paul. Before each match of the German national team, the zookeepers offered Paul food in 2 boxes that were colored with the flags of the opposing teams. And depending on which box Paul would go to first, the zookeepers made their forecast. Well, one might ask, does watching an octopus having lunch qualify as forecasting? I argue it does. Let's revisit our definition. Forecasting is the process of creating statements about outcomes of variables that presently are uncertain and will only be realized in the future. The zookeepers clearly had a process in place because they had marked the food boxes and had agreed on how to interpret Paul's behavior. The outcomes of the matches were uncertain at the time of Paul's food choice. And third, the outcomes of all the matches were realized in the future. So all considered, watching Paul pick the box with the Spanish flag on it and declaring that Spain would win against Germany squarely qualifies as forecasting. And as we will see, forecasting is a very important knowledge that has been applied across different sectors and industry, and it is extremely important to businesses as well. So one example here is the retail sector. We see that a lot of the retailers are now leveraging on the abundance of data associated with consumer transactions and use that to forecast the demand, because consumers exhibit heterogeneity in consumption patterns. the better you are able to predict the demand across the different consumer segments, the better your bottom line in general would be. So here we see one example of a grocery retail chain that uses machine learning techniques to predict demand for different segments of the consumers. Next, I would like to introduce to you the 3 basic principles of forecasting. First, forecasts are always wrong. Yes, forecasts are always wrong. If that is the case, then one might ask, why bother to do forecasting then? Well, we still need it because it is the foundation for activity coordination throughout a company. Said differently, we still need a reference target so that the company can produce an initial quantity for the season. So take for example, in the apparel industry, we produce an initial quantity, and then once the season starts and you get extra demand from the market, you can use those extra demand to revise the estimates that you obtained earlier on. So we need that so that we can pool resources and scale production accordingly. Second, forecasts are more accurate for groups of items rather than for individual items. And the reason is because when items are grouped together, under forecast and over forecast of individual items get cancelled out. So this is akin to averaging that we will see later on in this lecture. Third, forecasts are more accurate for shorter than longer time horizons. And this is pretty intuitive because as we start to forecast longer into the future, there are more uncertainties, and uncertainties create errors in our forecast estimate. So take for example, if you want to forecast the demand for ice cream tomorrow, if you look at the weather for today, it is more likely that the weather for tomorrow will resemble certain characteristics of today's weather. However, today's weather may not tell you a lot about the weather in 3 months' time. So let's go into introducing to you the 7 basic of forecasting models. So they are generally in order of complexity. I will cover linear regression very quickly, assuming that this has been introduced to you in previous statistics or econ classes. So I assume that you already know this, and I'll spend more time to cover the first 6 forecasting models. To do that, let's introduce to you some key notations. What we have here is A sub t. This is the demand observed in period t. F sub t is the demand forecast for period t. So assume that we have 7 periods, and in the second column, we have the A sub t, that is the demand. And what we want to do next is to forecast the demand F sub t. So for the first method, this is the naive forecasting model, and this is the equation. So the next period forecast is equal to the current period demand that has been realized. So we look at first period, we have the demand 130, and this is A sub t, and we cannot forecast for F sub t given the equation here, but we can forecast the demand for F sub t plus 1, which is this. So the next period will be equal to the current period. So what we have here is 130. So the next period forecast is equal to the current period realized demand. And we can do the same for the subsequent periods. I would suggest that you take some time at this point, pause the video, and make sure that you're able to follow and find the values for each of these periods. Now, assuming that you have done that, what are some of the pros and cons of this method? Well, some of the advantages is that it is extremely easy to use, very light on computation power. It uses very little data, right? So basically just 1 period before. And so it is very fast. Now, what are some of the cons? associated with this method, it is extremely vulnerable to noise because whatever spikes that has been realized in the past, it gets carried over to the next period almost immediately. And it ignores all the older data, right? Because you only consider one period before. So this might not be very reliable because variability would be high. So one might ask, hey, why not let's use more data points? And sure, we can do that.